Okay, so we will talk about solar energy, harnessing solar energy today. What we want to do is we want to take sunlight and convert it into electricity. Okay. Now there are two ways of doing it, two very different ways of doing it. Yeah. And let me show you this. So before I do that, I'll give you a big picture of solar energy. Okay, so let's look at this graph. What this says is, okay, do you guys remember how much electricity does Hoover Dam produce? A big plant like Hoover Dam? 1 gigawatt, right? 1 gigawatt is 1 billion watts. Okay, so what that means is with 1 billion watts, oops. What you can do is 10 into 10 to the 6 into 100 watt. So with 1 billion watts, with the Hoover Dam, you can turn on 10 million 100-watt bulbs. That's what you can do, all right? Or this is 1,000 watts. You can think of, you can run a house with 1,000 watts, okay? So you can run 1 million homes. That's what you can do with the Hoover Dam, okay? A terawatt is 10 to the 12 watts. It's 1,000 gigawatts. So a terawatt is 1,000 Hoover Dams. Okay? That's what that number is. So to run the world, you need 16,000 Hoover Dams running all the time. Okay, so that's what you need currently. 16,000 Hoover Dams running all the time to run the world. This is how much sunlight is falling on the earth all the time. Okay, so somewhere on the earth, for a given location, you get sunlight only about half the day, you know. So you can see that there's plenty of sunlight falling to run the world. You can just run the world just on sunlight. Okay. So let me show you. What else can you run the world on? You can run it just on wind. And, you know, when the sun is shining the brightest, the wind is the slowest, and when the sun is not shining the brightest, the wind is blowing the hardest. So they're complementary. So that's another good thing. And those two are green sources. And what does that mean? Yeah, you don't put carbon dioxide in the atmosphere. Okay. What this tells you, what this number tells you is, see, this is 900 terawatt per year. So let me give you, so this is 16 terawatts. So 900 divided by 16 terawatts. Let's do 900. Okay, so that number tells you the following. Terawatt year divided by 16 terawatt. This is 56 years. Okay. So what this number tells you is if you ran the world entirely on coal, you would have enough coal for 56 years. Okay? And of course, the problem is we don't want to use that. We want to leave the coal in the ground because we want the carbon to remain in the ground, not in the atmosphere. Okay? So for your generation, you want to switch to these guys. Okay? All right. So there's plenty of sunlight falling to run the world. Okay? And so to give you a perspective, okay. So these black dots, if you cover these black dots with photovoltaic cells, solar cells, you can run the world. That's all you need to do. Okay, so 300 kilometers by 300 kilometers photovoltaics. 300 kilometers is roughly, let's say, you can think of it half the size of Florida. Okay? 6 solar panels like that, and you can run the world. What is the problem with it? Why aren't we doing it?
Expensive?
No, it's one of the cheapest.
Like big oil or something?
Hmm?
Big oil? Big oil won't let us do it?
Well, that's part of the deal, but if you come up with a better idea, you can just become richer than them, and then to hell with them. So what is the real reason?
Batteries?
Hmm?
Did you say batteries?
Batteries. Okay. So the sun, for a given location at night, what do? You'd have to store electricity in batteries, and batteries are right now expensive. That's the deal. Okay? So you come up with a cheap battery technology, and nobody can stop you. Okay? So it can be done. Okay. Now, this photovoltaic cells. So these are photovoltaic cells. This is sunlight falls on them, and it converts it directly to electricity. Okay.